Hello, everyone. Sorry about that resizing. Today we are talking about exponential growth and decay. Yesterday, the last video, we talked about the equation for exponential, which was the generic equation is y equals a times b to the x, where a is our y-intercept and b is what we call our growth factor. So there are many things in the real world that grow faster as they grow larger or decrease slower as they get smaller. These types of phenomena, loosely speaking, are known as exponential growth and decay in the case of decreasing. In today's lesson, we'll look at both growth and decay. So example number 1, the number of people who have heard a rumor often grows exponentially. Consider a rumor that starts with 3 people, where the number of people who have heard it doubles each day it spread. Why does it make sense that the number of people who have heard a rumor would grow exponentially? Well, because the longer it spreads, more people keep telling it. So fill in the table below for the number of people n who knew the rumor after it has spread a certain number of days. So it started with 3 people. And then each one of those people told 2 people. So it doubled. Now we have 6. So each one of those people tells 2. So now 12 new people know. And then each one of those 12 tell 2 more. So now 24 new people. And 48 and 96. It keeps going up by multiplying by 2. So now, example 2, we'd like to determine the number of people who know the rumor after 20 days. But to do that, we need to develop a formula to predict n, the number knowing the rumor, if we know d, the number of days. For the following number of days, fill in how you would calculate your values based on extended period of products of the number of 2. So when we did day 1, we did 3 times 2. Day 2, we did 3 times 2 times 2. Day 3, we did 3 times 2 times 2 times 2. So hopefully you notice that each day there are that many 2s. So now using the pattern you developed, write a formula giving the number of people who know the rumor n if you know the number of days. Well, you can see that we do 3 times 2 to the d, because each day we multiply by 2. Oh, and it's not a, it's n. Sorry about that. So then we can use that formula to figure out how many people would know it after 20 days. So we're going to do n equals 3 times 2 to the 20th. So on your calculator, we're going to do 3 times 2 to the 20th power. And we can see that it's 3145728. So 315,728. Exponential growth can be very fast. Assuming your equation from B holds, how many days will it take for the number of people knowing the rumor to surpass the population of the United States, which is approximately 315 million? Show your calculations to support. So we can do 3 times 20 to some power. So we can try. So if I do 3 times 20 to say 20 days is that. So let's try 25 days. Whoa, 25 days is way too much. So let's try 3 times. Oh, I did 20. Sorry. So let's try that again. 3 times 2 to the 25 days. is 100 million. So we need 315 million. So we're pretty close. So we did 3 times 2 to the 25th. And we got 1,006,63296, which is 100 million. So each day that number doubles. So 26 days should double, and it did. So 3 times 2 to the 26th gives me 201,326,592, which is 200 million. If we go one more day, we should exceed and we do exceed. So 3 times 2 to the 27th equals 402,653,184. So it's 27 days. Now we could have found that another way using our calculator by going to y equals and do 3 times 2 to the x power. And then if we look at our table, we are looking for 315 million. So if we go up, 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 we can see that it starts to write it in scientific notation. And at 27 days, we have our 402 million. Now let's look at developing a fairly simple problem for exponential decay. So for exponential decay, we're looking at Helmut from Finland is heading towards a lighthouse in a very particular way. He starts 160 feet from the lighthouse. On his first step, he walks half the distance to the lighthouse. So if he starts 160 feet, step 1, he's at 80 feet. On his next trip, he walks half of what's left. So 80 then becomes 40. On each consecutive trip, he walks half the distance left. We're going to model the distance d that Helmut has remaining to the lighthouse after n trips. So we do 180, 80, then next we would have 40, then 20, then 10. Each entry in the table could be found by multiplying the previous by what? Well, it's a half. We have to think about it as multiplying always because the exponential is always multiplication. So like in 2a, we want to use this process to relate it to multiplying. So first we did 160 times a half. Then we did 160 times a half times a half. And hopefully you're noticing that each day or each segment is equal to the number of 1/2. So our formula would be d equals 160, 1/2 in parentheses to the x power. So now the question is, how far would Helmut from the windmill after 6 trips? So we're going to do d equals 160 times 1/2 to the 6th. And we do that on our calculator. So 160 times, use our fraction option, 1 divided by 2, close parentheses to the 6th power. And that means we're 5/2. And so after 6 trips, he's 5/2 or 2.5. What is our unit? Feet. Helmut believes he will reach the windmill after 10 trips. Is he correct? So let's try. So we're going to do 160 times 1/2 to the 10th power. and he's 5/32 feet. So he's not actually there, but in reality, yes. Yes, in reality, but no, because there's still a distance. He will never actually reach because it will never be 0. Why is the domain of this function whole numbers? Well, the domain is whole numbers because it's number of trips. He can't take a partial trip. Okay, and that's it for today. We'll finish the rest of the notes tomorrow in class.